and I need to find some psi such that this rho 1 is reduced density matrix of this psi set. This is what I need to find. So then what he said, this is the formula to find the psi, and this psi is nothing but some C I alpha. So let us assume here that I is also 1 to 2 and alpha is also 1 to 2. That means let us say this is the qubit, which is in C 2 cross 2. And let us say this is my D1. So D1 is equal to 2. And let us also assume that D2 is also equal to 2. Okay, the other system. So this is a 4x4 system, a bipartite system. Now I need to find a PO state corresponding to that bipartite system using this formula. So if I want to use this formula, I have to vary it over gamma. So gamma could be equal to 0 or 1. Okay, because I have written in terms of 0, 0, 1. Otherwise, I could have written 1, 2. So it is 1, 1, 1, 2, 2, 1, 2, 2. So gamma is varying from 0 to 1. Ij, they are also varying from 0 to 1. Okay, I have to find it. So if I just write it down, what is my system of equations? What is my rho 1, 0, 0? That means I equal to 0, j equal to 0, and this gamma could be 0 and 1. So if you take gamma equal to 0, so this will be 0, 0, and j is already 0, and gamma is 0 here, plus, okay, there was a bar, I missed, plus, there will be I and j are fixed 0, 0, but gamma could be 1, so it is 0, 1, and this is 0, 1, this. Okay, this is one equation. And then I can write 1, 0, 1. By the way, since this is a Hermitian matrix, I know that this is equal to bar of this one. This is a conjugate of this one. Okay. So rho 0, 1 means what? I equal to 0 and j equal to 1. Okay. So I equal to 0 and j equal to 1, I mean bar. And gamma equal to 0, 0 is this, plus. Then I equal to 0, 1. I equal to 0 and j equal to 1. And gamma is 1. Yeah. Similarly, I can write rho 1, 1. Okay. Which is equal to rho 1 of 1, 1. Which is equal to what? I equal to 1, j equal to 1. So this is 1, 1, first this 0, plus 3, and this is 1, 1. So this is 1, 1, then gamma equal to 1. This 1, this 1, this 1. So then I know is given to me. I need to solve this equation. But when you are solving the equation, there can be multiple solutions. So that means whenever I say I'm to purify the psi state, and that means the purification is not unique. Because when you are solving a system, if it is solvable, then there can be many solutions. So I can have many purifications corresponding to a given mixed state. So if I just want to solve, and just for the sake of curiosity, there are how many variables? There are 4 variables here. So just in order to simplify the system, you may assume that sum of this is 0. So let's say C 0, 1 equal to. Then what you are getting? So if C is 0, then the first system will give me C 0, 0, C 0, 0 bar is equal to rho 1, 0, 0. But see, this is, you may also assume that suppose C 0, 0, I want to be a complex number, a real number. That also can be done. So then in that case, I'll just remove this. And I can just write C square. And that will give me C 0, 0 to become square root of rho 1, 0, 0. I already get my value. Then from this, okay, I already know C 0, 0 from here. And I put C 0, 1 equal to this. So from there, I can get the value of C 1, 0. This I'll get as this. Okay, divided by C 0, 0, which is this. And once I know this, then I can find the value of this C11. Even if we want to take C1 to be equal to real, now it's very simple. Then C11 square will be equal to C10, which I already know here. Okay. So this and its dagger. Okay. So C10 bar minus rho 1, 1, 1. And then I have to take a square root. So at least I get, using this way, at least I get one solution for this C00, C10, C01, and C11. So I know my state psi. So this is the way to compute purification of a given density matrix. The interesting part here is that so this, let's note it down. That the important thing here is the second system need not have a physical reality. Okay, I'm doing it just for say, let us just doing for the sake of mathematics. But this is very much useful because instead of dealing with this one, I'll now deal with psi. And this is a pure state. I don't have to deal with this one. But if I want to measure some quantity of this one, I'll take just the partial test of this one and I'll get back the value of the observable. Okay, or the measurement of a measured value of an observable. So I can find it out. So I'll deal with psi. Okay, and that's it. So this has a lot of applications, and this is called the purification procedure of a mixed state. Okay, this is very, very important. Now, so this is one application of reduced density matrix. And what is that? Any density matrix in the world can be considered as a reduced density matrix of some bipartite system. And it's a reduced density matrix of a pure state. A reduced density matrix of a density matrix which corresponds to a pure state. So it is another look at the density matrix, that any density matrix can be considered as a reduced density matrix. Now, okay. Now, let me introduce a very important concept, which is called, okay. So I have a bipartite system. Okay. I talked about a single system. Okay. Now I have a one partite system, let's say. I just have a single system. Now I have two systems. I can have multiple systems. But let us restrict ourselves to only two bipartite systems for the case of theory. But for the case of computation, you can always consider multipartite state, like multi-qubit system. So we talked about evolution. Okay, evolution of a state, which is given by the Schrodinger equation. So we talked about Schrodinger equation. So we talked about evolution of some psi, some pure state, using Schrodinger equation. Then we also said evolution of rho, which is evolution of a density matrix. But we did not discuss evolution of a bipartite state. It will be similar because whenever I say bipartite state, if it is pure, then it will follow this one. That's it. If it is a density matrix, if it is mixed, then it will follow this definition. So this already we discussed. But there is a catch. And the catch is, when you talk about evolution of a bipartite system, the corresponding subsystems are also evolving. Then the question is, from the evolution of the entire bipartite system, can I find out the rule, or can I find out the theory of the evolution of a subsystem of the bipartite system?